Hi, today we are looking at the definition of the derivative. So our definition of the derivative is the derivative of a function f with respect to x is the function f prime and is defined as f prime of x equals our limit as h goes to 0 of f of x plus h minus f of x over h, where f prime is our tangent slope to our function of f. Now, in other words, it is an equation that gives us the slope of our starting function. Look a little bit at derivative notation next. So anytime we have this symbol here after something, it is prime. So this would be y prime, this is f prime. If we have dy over dx, that's dy dx, or the derivative of y with respect to x. If we have df over dx, that's df dx, or the derivative of f with respect to x. Okay, so we'll look at an example. We want to use the definition of a derivative to find the slope of a tangent to the curve f of x equals 1/2 times x squared plus 2. And we want to find that slope at x equals -2, 0, and 3. So first thing we're going to do is find our derivative so that we have the equation of the slope of this function. So we're going to use our definition of the derivative to do so. So if you recall from just previous page, f prime of x is equal to our limit as h goes to 0 of f of x plus h minus f of x over h. So we'll then insert our function into this. So we've got our limit as h goes to 0 of f of x plus h. So that's essentially this function, but we're substituting in x plus h everywhere we added x squared. So it'd be 1/2 times x plus h squared plus 2. And then we have minus our function, and it's just x here, so it's just minus this entire function. Now I tend to substitute it all in brackets, and then in the next step, take care of expanding it out. So we've got 1/2 x squared plus 2, and that's all being divided by h. Okay, so that's our limit as h goes to 0 of 1/2. If we expand this binomial out, so we'll end up with x squared plus 2xh plus h squared plus 2. And then we'll apply this negative to both these terms. So minus 1/2 x squared. And then we've got minus plus 2, so minus 2. And that's over h. Now, one thing that we can notice right now is essentially we've got plus 2 and a minus 2, so those can cancel out. We'll multiply this out in our next step. So we've got our limit as h goes to 0 of 1/2 times x squared is 1/2 x squared. 1/2 times 2xh is just xh. And then 1/2 times h squared is plus 1/2 h squared. And then we have minus 1/2 x squared. And that's all over h. Now, once again, we can see we have some stuff that cancels out because we've got positive 1/2 x squared, and then we've got minus 1/2 x squared, so those essentially cancel each other out. So I'll just rewrite this equation. I'll just bring up here to do so. So we have equals our limit as h goes to 0 of xh plus 1/2 h squared over h. So what you'll notice is now that we've simplified it down to this by getting rid of our other terms that canceled out, every term remaining has h in it. So we can simplify. So that gives us our limit as h goes to 0 is x plus 1/2 h. Now, if h is going to 0, 1/2 times h will essentially go to 0. So in this case, our f prime of x is just equal to x. So if we want to find our slope at these x values, we can just substitute directly in. So f prime of -2 would just be -2. F prime of 0 would just be 0. And f prime of 3 is going to give us 3. Okay, next example, we want to find the equation of the derivative of f of x equals x squared plus 3x plus 2 and find our slope at x equals -1, +2, and +5. So we're going to do this the exact same way. So we're going to start out with our definition of the derivative. So once again, our definition of the derivative is f prime x is equal to f of x plus h minus f of x over h. So now, just like last time, we will substitute our functions in here and here. For this one, we need to substitute x plus h in for every x that's here. For this one, we just substitute it in as is. So you've got f prime x is equal to x plus h squared. And sorry, I realize I made a mistake while writing this out. I forgot to include that is the limit as h goes to 0. So therefore, it's our limit as h goes to 0 of f of x plus h minus f of x over h. So we've got our limit as h goes to 0 of x plus h squared plus 3 times x plus h. And then we've got plus 2. And then we're subtracting our original function, so minus x squared plus 3x plus 2. And that's all over h. So we'll go through and start simplifying this. So we've got our limit as h goes to 0 of x squared plus 2xh plus h squared plus 3x plus 3h minus x squared minus 3x and I realize I once again made a small mistake because essentially I expanded this out here. I multiplied these out, but I forgot to include this plus 2. So we've got plus 2, and then we'll apply this negative. So minus x squared minus 3x minus 2 all over h. So that gives us our limit as h goes to 0 of, we can see that positive x squared cancels off negative x squared, positive 2 cancels off negative 2, positive 3x cancels out with negative 3x. So what we're left with is 2xh plus h squared plus 3h all over h. What you'll notice now is essentially every term has h, so we can cancel out an h in every term. So we've got our limit as h goes to 0 of 2x plus h plus 3. Now, if h is going to 0, that means that this term goes to 0, which means our f prime of x for this function is 2x plus 3. So now we found our derivative of that function. We'll now figure out the slopes at these individual places. So we'll just do that up here. So I'll just rewrite our equation up here. So we've got f prime x equals 2x plus 3. So if we're looking for a slope when x equals -1, that'd be f prime of -1 is equal to 2 times -1 plus 3. Which just gives us 1. Then f prime of 2 would be 2 times 2 plus 3, which gives us 7. And then f prime of 5 gives us 2 times 5 plus 3, which gives us 13.